All right. Physics 20s, we're done with gravitation to a certain extent. We're going to talk about circular motion. You can imagine that circular motion and gravitation kind of go together um, when we look at planets and their orbit around the sun. But to start this unit, we're going to talk about uh, a particular type of circular motion. That's uniform circular motion. So uniform circular motion is circular motion that involves objects traveling at a constant speed in circular motion. Kind of like if there's something in your tire and you're just going at a constant speed around and around and around. So we're not changing the speed of the circular motion. Some things that you might be familiar with riding a bicycle is that if it's wet outside, you quite often get your whole backside wet when you're riding a bicycle because the water gets kind of scooped up by your tires and fired onto your back. And part of the reason why that is because there's a tendency for objects to stay in uniform motion, traveling straight, unless there's a force holding them on. So at this point, the water's kind of in the tire, but as the tire keeps rotating, it has a tendency to want to keep traveling straight, and it heads straight off onto your back. And so that can happen when you're riding a bike, and a bike is a good example of the tires being uniform circular motion at different times. You can same thing here. You can think of a rock being caught in a tire and how it travels around. At any instant, the velocity is called tangential, meaning that if the rock comes off at any moment, it would travel straight at a tangent to the circle, not radially, not straight away from the center of the circle, but tangentially, um, because objects want to stay in uniform motion. And so, what ends up happening is for something to be able to travel in circular motion, there has to be a centripetal acceleration and a centripetal force. The word centripetal means center seeking, and these forces are directed towards the center, and that's what keeps things traveling in circular motion. You can think of this when you're trying to throw a discus. Way back in junior high, when you first threw a discus, you grab hold of the discus, you spin in a circle, and your arm is pulling that discus in towards you as you're spinning, and eventually you let it go. Well, when you let it go, if you're spinning around in this direction, when you let it go, it's going to travel straight as soon as you let it go. It's not going to go straight out, but it's going to go straight in this tangential direction. And there has to be a force that's pulling it towards the center, which is your arm when you're throwing a discus, or in the case of you twirling around something on a rope, there's a rope here that's pulling towards the center that allows that object to travel in circular motion. And so we have centripetal forces and centripetal accelerations, meaning center seeking, that are directed towards the center of the circular motion. And we have velocities, which are tangential, meaning that if at any point the force of the acceleration doesn't exist, the velocity of the object would be straight out, um, tangential to the circle, not radial. These are called radial directions. In the direction towards the center, those are radial directions. Okay, so here's a little chart summary of that. Well, there are some mathematics that we need to be get comfortable with circular motion. One of them deals with concepts of period and frequency. Um, if you look at a baseball that's spinning, and you take a look at this point P, as the ball spins around, eventually point P ends up coming back to the top position. The time that it takes for the baseball or any object to make one complete revolution is called the period. That's the time it takes to make one revolution. Well, um, the other flip side of that is the concept of frequency. Well, frequency is not a measure of the time it takes to go around once. Instead, it's the number of rotations that occur per second. So, We have period, which is the time of one complete revolution, and frequency, which is the number of rotations per second. And the nice thing about those two numbers is that they're just reciprocals of each other. So if you have a period of 2 seconds, then your frequency would be 1/2, or a half. If you had a period of 10 seconds, then your frequency would be 1/10. They are just reciprocals of each other. Period, the standard unit for period is seconds, and the standard unit for frequency is per second, or hertz. And what hertz represents are cycles per second. So another common unit for frequency is RPM, revolutions per minute. So you might see an engine, and the tachometer on your vehicle might read 2,000 RPM. Well, that's saying that it's making 2,000 revolutions every minute, which is fairly quick spinning. Well, if you want to take RPM and change it to revolutions per second, you just have to divide by 60. Just like if you have revolutions per second or hertz and you want to get to RPM, you times by 60, just because there's 60 minutes or 60 seconds per minute. So here's an example, a hard drive. Older hard drives, and still a lot of the hard drives have these rotating high density disks, and they spin. So this high speed hard drive spins at 0.00833 seconds. That's the time it takes to make one revolution. So if I wanted to know the frequency in hertz, I would go 1 divided by that number. It would tell me that the disk spins 120 times per second, which is pretty significantly fast. On the other hand, if we change it to RPM, we times by 60, and you find out that it makes 7,200 revolutions per minute. And so that's the way that all of these units kind of interchange to each other. Um, the other concept or quantity that we're quite often worried about with circular motion is the speed of circular motion. And because it's uniform circular motion, we can kind of make use of this formula that we did in the very first unit, where speed is distance over time. And if you uh, keep this in mind, that speed is distance over time, and then look at the way something travels in a circle. If I look at my baseball here, the distance this point P would travel would form a circumference of a circle. And so the formula for circumference is 2 pi times radius, or pi times diameter. So 2 pi times radius, the distance, and the time of one revolution is the period. And we use capital T for period. And so if you take a look here, when they're looking for formulas for uniform circular motion, it's distance over time, but the distance is the circumference, and the time is that special time period called the period. And so if we were looking at the Earth follows a fairly circular orbit around the sun, and its orbit is about 1.49 times 10 to the 8th kilometers, and it takes 365 and a quarter days to make a complete revolution. If we were to figure out how quickly we're traveling around the sun, we would go 2 pi times the radius, change the radius to meters, divided by the period, 365.25 days, times by 24 hours in a day, times by 60 minutes per hour, times by 60 seconds per minute. That would give you the complete time it takes in seconds for us to travel around the sun in 1 year. Well, if you take that distance divided by the time, you find out that while we're on the Earth here, we're traveling close to 30,000 meters every second. And if you want to change that to kilometers per hour, you find out that it's about 107,000 kilometers per hour. So we're really traveling quickly around the sun. Another example here. Pebble is stuck in the treads of a tire at a distance of 36 centimeters from the axle. It takes 0.4 seconds for the wheel to make one revolution. What is the speed of the pebble at any instant? Well, in that case, If we're looking at our speed is 2 pi r over t, the radius is 0.36, change it to meters, divided by the time, 0.4 seconds, and you can find out um, the tire is rotating at 5.7 meters per second. Now, to make it even more mathematical, there's a formula that represents the acceleration of an object in uniform circular motion. So, how big of an acceleration is needed to keep something in circular motion? And that's this formula right here. So, if we were asked for the acceleration needed to keep something in circular motion, we would have to know the speed that it's spinning at, and then we would square that speed and divide it by the radius that that object has while it's traveling in circular motion. So it's a fairly uh, simple looking equation, but we can make it look a lot more complicated um, when we start doing questions with it when we don't know the speed. So this one's a DVD disc that has a diameter of 12 centimeters and a rotational period or time of 0.1 seconds. What's the centripetal acceleration? Well, the first thing they did in the solution here is take the diameter and divide it by 2 to find out the radius. Then they made use of the formula for speed. The speed of something in circular motion, uniform circular motion, is 2 pi r divided by the period. Well, 2 pi r is going to end up being 2 pi times 0.0600 meters, and the period is going to be the 0.1 seconds. When you divide those two, you end up with 3.77 meters per second, which is just the speed that the DVD disc is spinning at. Um, then the final step to finding the centripetal acceleration is to say, well, the centripetal acceleration is speed squared divided by the radius. So all that work that you found used to find the speed, you would square that speed and divide it by the radius, and you would get the acceleration, centripetal acceleration of the DVD disc. How big of an acceleration does it face? Um, uh, in class at other times, I've shown videos about these fast spinning disc players. There's a Mythbusters video where they take these fast spinning discs and they spin them so fast that they actually shatter and the shrapnel flies apart. And they use one of those test dummy things and they find out that the shrapnel is moving so fast that it actually embeds itself in their crash test dummies. So at some point, spinning these discs so fast actually ends up being extremely dangerous for the um, people nearby. All right, that'll be good for talking about concepts like speed, uniform circular motion, uh, the difference between period and frequency, and leads us into a calculation for finding the acceleration. The next step that we're going to talk about is going to be about the centripetal force involved with these type of things.